So now we want to approach how do we actually find a limit? Okay, so there's several methods we'll be able to do. In the last video, we kind of looked at solving a limit using a graph, and we'll kind of look at that a little bit more here. We could also use a table. We could use algebra, like we saw in the simplifying example. We can just use direct substitution. So there's several methods we'll have that we'll look at videos for each one of those. So let's look at a table first of all. And tables and graphs, I feel like kind of go hand in hand, right? You can kind of you can make a table without a graph, but the table is helpful if you have a graph to go with it, and vice versa. So let's look at first at the function sine of x over x. Okay. And we specifically want to know what is the limit as x approaches 0 of sine of x over x. So in general, it's a good idea just to plug the point in, right? So first of all, just find, does f of 0 exist? And if it does, what is that point? Because even though it might not end up being the limit, it's still helpful to know. It might end up being the limit, but maybe it won't. So if we just plug in f of 0, we get sine of 0 over 0. We already have a problem here because we have a 0 in the denominator, right? Sine of 0 is also actually 0. So we get 0 over 0. So we get an indeterminate form, so it's not really useful. It doesn't give us any information. Okay, well, what if we go over to the graph? Okay, so this is a graph of sine of x over x. And again, it's hard to see on the graph, but if you hover over this, you'll see that at 0, it's undefined. But it seems to pretty clearly be going to 1, right? So it's never actually touching 1. But it does seem like that is the point that it is approaching. But it's hard to know exactly. Like, what if the point is like 0.99995 or something, right? It's hard for us to know. It does start rounding to 1 as it gets really close because this graphing calculator only rounds to 3 decimal places. But, maybe it's like 0.999999997 or something, right? So how do we know it's 1? Well, another way we can confirm our suspicions is by using the table. So here we have a table of values, already pre-made because, these are kind of, sorry, I was trying to drag the table up. These are a little bit, tedious to make. So I just figured we can go ahead and just look at the table here. So we can see these are the values that maybe we'd want to plug in. So what we do is we look at both sides of 0. So namely the right side where we have 0.1, 0.01, 0.001, 0.0001. So numbers getting closer and closer to 0. And then doing the same thing on the left side, right? So we have negative 0.1, negative 0.01, etc. So these numbers are getting closer and closer to 0 as well. And then we look at what are the outputs getting closer to. And we can see that we just keep adding more 9s in there, right? 0.99, etc., 0.9999, etc., 0.9999999, etc. And it just keeps going. So we can see this is clearly going to 1, or 0.9 repeating, which is the same as 1. So both the graph and the table kind of help to confirm our suspicions that it's going to 1. So this is kind of how we would approach solving this limit then. So based on this information, we say the limit as x approaches 0, sine of x over x equals 1. Now, there are some things that we'll look at later which might help be a little more precise in a case like this where it's a little bit tricky, right? Because you're using a trig function. Other functions might be a little bit easier. Maybe we can do some algebra to simplify the equation, for example. All right, so let's look at another example. Again, rather than copying the whole table here, because these are pretty tedious calculations. Let's just go ahead and look at this problem I have here this is from the OpenStax calculus textbook. So one of their example problems. So this one's looking at the limit as x approaches 4 of the square root of x minus 2 divided by x minus 4. And this is one, okay, so first of all, if we plug in 4, we're going to get 0 over 0 again, right? This is going to be the square root of 4, which is 2, minus 2 is 0. And then on the bottom, we'll have 4 minus 4 is 0. And this one, maybe there's some algebra that we could do. So we'll look at that when we look at the algebraic techniques for solving limits. But right now, let's just focus on the table, and then we'll look at the graph as well. So as we look at values getting closer and closer to 4, so we look at 3.9, 3.99, 3.99999, we see that this is getting closer and closer to 0.25, right? So with the last value being 0.250000016, and on the other side, we're looking at values getting closer to 4 from the right. So at 4.000001, we get 0.2499999, right? So it seems like this is getting closer and closer to 0.25. Okay. So let's go ahead and use the graph to confirm those suspicions or deny them, maybe. Okay. So we'll plot the square root of x minus 2. Put that in parentheses, divided by x minus 4. And I encourage you to use this calculator or a different calculator of your choice. Because it's just good to look at these problems. Even when we start to do them algebraically and you might not need it. Okay, so again, undefined at 4. But, just look at the graph, right? It looks... if you zoom out, it just looks like one continuous line. It looks like it's very blatantly passing right through that point. It doesn't look like there's any bump in the road at all. It's only when we zoom in on that exact point that we see that it is undefined there. So this is what we kind of mean by a limit, though. It clearly looks like the function is going to pass through the point for 0.25, right? Or for 1/4. So even though it's undefined there, we still say that the limit as x approaches 4 is indeed 0.25 or 1/4.